Greetings, I am Kenneth Brown, a first-year mechanical engineering student.
I am Deja Reed, a second-year pre-med biology student.
And I am Alon Foy, a first-year pre-pharmacy student. And today we are here to talk about Chapter 4.1, Extreme Values of Functions. Maximum and minimum values are called extreme values of the function f. Absolute maxima or minima are also referred to as global maxima or minima. Extreme values of a function consist of multiple components. The maximum and minimum points are broken down into absolute minimum and maximum.
Well, you can see here on the function that we drew, well, this crazy function here, you have an absolute maximum here and an absolute minimum here. These basically represent the points on the function where it's at its highest and at its lowest points.
Theorem 1, the extreme value theorem, states that if f is continuous on a closed interval of a and b, then f attains both an absolute maximum value m, capital M, and an absolute minimum value of lowercase m on the interval of a and b. That is, there are numbers x1 and x2 in the interval a and b with f x of 1 equals m and f x of 2 equals capital M, and m is less than or equal to the function and less than equal to the function of m for every other x in a and b.
For our second example, we have f of x equals x squared. So on this function here, we have an absolute maximum at y equals 4 and an absolute minimum at y equals 0.
Local maximum or minimum values and points are the same as the absolute, besides it being the maximum or minimum in a certain interval on the graph or interval of the function f. These local extrema may also be referred to as relative extrema.
Back to picture 1 of our original function, we've used this rectangle to basically show an interval. So we labeled our local maximum and our local minimum. These points are the highest and lowest points within a closed interval.
Theorem 2 states that if f